Made that happen. Hello, welcome. Good morning. How's everybody doing today? Good. The lights just got a lot brighter. So we're here this morning to talk about best practices for securing serverless applications, because of course security and compliance are always primary considerations in everything that we build, whether it's in the cloud or elsewhere. But as we push the boundaries of innovation, we want to make sure that we're also maintaining a high security bar, of course, right? I see some nodding heads. I really love building with serverless because I can deliver a lot of customer value very quickly while building on a secure baseline that we'll talk about in just a few minutes, and have a system that's going to scale when I need it to, or if I need it to. So in our session today, we're going to explore best practices for how you can continue to build on that secure foundation of serverless while finding the right balance between moving fast or innovating and security. My name is Josh Kahn. I'm the worldwide tech leader for serverless here at AWS. And joining me,
my name is Heikki Park. I'm a specialist SA covering serverless as well. But I'll be back in a short while.
Cool. So we view serverless as a strategy or an operating model that allows you and your builders or developers, whatever you want to call them, to focus on delivering or on delivery. So AWS is going to take away a lot of the undifferentiated heavy lifting, including various aspects of how you secure your workload. AWS is going to take those things on when you build with services like AWS Lambda, Amazon Event Bridge, and AWS Step Functions. So when we pick serverless as our strategy, our approach to both application architecture and security is going to change a little bit as well. And that approach allows us to rethink some of what we're doing from a security perspective. So we're going to be kind of shifting that shared responsibility model between you, the customer, and AWS. With serverless, we're building from a secure baseline, which we'll talk about on the next slide. We're shifting a lot of the security operations, or the burden of those, over to AWS. Things like encryption, port access, isolation, not allowing privileged users. A lot of that's taken care of by default, or just with a pretty quick checkbox. We can also leverage deep integrations with other AWS services like GuardDuty and Amazon Inspector. We're going to talk about those towards the end of the talk today. But one of my favorite aspects about building with serverless is that I can use one common system to manage fine-grained access control across all of these services. And that's AWS IAM, or Identity and Access Management. And I can use IAM to control access to both the control plane and the data plane for these services. So not just how they operate, who has access to go create a new DynamoDB table, for example, but also who can invoke a Lambda function, or what can invoke a Lambda function more likely. So while some aspects of building with serverless are going to stay the same, there's some things that are different as well. So first off, these services are fairly ephemeral, right? If you've used Lambda, that Lambda function execution environment or sandbox is going to spin up. It's going to go take care of that particular execution. It's going to do whatever you've asked it to do, and then it's going to go away. Maybe after some period of time, right, that sandbox is going to go away, but it really just takes care of its job, and then it's done. These applications, you're also not building a monolith so much, right? It's not one big block on the diagram. There's a bunch of little building blocks that we're putting together, which means you have a diffused perimeter across those services. But again, we can use IAM there to control access to both what those services are able to do on your behalf, or who has access to configure them. And then we're going to talk not quite a bit, but a bit about developers and builders and what they're actually delivering in this world. So in traditional applications, right, your developers are probably writing code, some way, shape, or form, .NET, Java, Node, Python, whatever your flavor may be. But when we're building with serverless, a lot of times those folks are going to be delivering not just application code, but some infrastructure configuration as well. In fact, they might only be delivering configuration. So it does look a little bit different. We're going to talk about the interplay there. What doesn't change? You still need to secure your data, right? We still want to make sure that only the right principals, the right parties have access to it. We still want to write quality code, or as quality as it can be. And we want to protect against vulnerable dependencies. Higgy's going to talk about a way to do that towards the end. And then least privilege is a pretty common concept in cloud, but we're going to talk about that a little bit more and how you might want to shift some of that responsibility to the folks building things in your organization. So that secure baseline I keep talking about, there's a bunch of things that come with it, like the ability to use IAM to control access. Encryption in transit and at rest comes kind of standard or with a checkbox. You can get runtime isolation, prevent network access to various compute resources. There's no privileged users, et cetera. Right? So there's a bunch of stuff that comes for free. But one of the things we always like to remind you is that security here is a collaboration. Depending on your organization, you might have a team called something like this or somebody that embodies these principles. And they might be a centralized capability, or you might embed these folks in your delivery teams. There's probably a security team out there that's making sure that you're abiding by some policies and compliance requirements. They might define some IAM policies or roles or various permissions. A lot of organizations these days also have platform teams, or what we tend to call platform builders. They're building guardrails, and we're going to talk about guardrails because we want to give developers and builders some flexibility, ideally to try new things. All of the services that we're going to talk about evolve over time and get better, right? You all spent like the last couple weeks, like I did, trying to keep up with the slew of announcements. So these are getting better. We don't want to restrict people so much that in dev environments, they can't at least test things out. They might also be responsible for networking, code scanning, some of those responsibilities. And then, of course, we talked about your development teams. They're delivering application code and some sort of infrastructure definition. I don't care if it's CloudFormation or AWS SAM or CDK or Terraform or whatever you might choose, as long as it works for you. So we want to find the right balance between innovation and security, delivering customer value. And what we're going to focus on through the rest of this session is some best practices that you can use to help find that balance. But security is a huge topic. Higgy and I spent a whole bunch of time trying to figure out what we could talk about in the span of 55-ish minutes to an hour, right? We could literally spend all day just talking about various security topics. So there was this paper that we found that kind of helped us narrow in on what we're going to talk about today. This is an empirical review of a lot of the most critical or common vulnerabilities in some microservices that these folks found. So we're going to focus in on these 6 topics. That's going to kind of be our organizing factor for the rest of the day, or the rest of the hour, I should say. We could be here all day. We're going to move fast. We're going to try to give you an overview of all of these different topics. And then we're going to give you some recommendations on how to go deeper. A lot of the slides are going to have a QR code in the upper right-hand corner where you can kind of scan things and go a little bit deeper. They'll also make the video and the deck available to you after reInvent. So as we go, we're going to use this very simplistic architecture as kind of our guiding light. So it's got an API gateway as the front door. So this is presumably a web API of some sort. That API gateway is going to invoke a Lambda function. That function is going to write some data, let's say, to DynamoDB. And then it might also call some other service. Right? That's important because when we want to secure service-to-service communication in some way, shape, or form, you can use IAM to do that too in this case. And then we're also going to talk about some of the stuff that gets delivered, infrastructure definition and application code. And then in the bottom right-hand corner, we've got this little key. And across those 3 teams, right, security, platform builders, and development, we've tried to give you a sense of who might be kind of the primary owner for that item, right? Although, depending on your organization, that might differ. Your organization, depending on your security controls and compliance needs, some of the things we talk about might be a little bit different. But our hope is that this gives you a great starting point. So this is a web API, right? It's sitting out there, maybe on the public internet. So we're going to get started by talking about how to protect against injection attacks, which again, in that empirical review, was one of the most common vulnerabilities that they found. So there's a few different tools that we can use, right? These are serviceful services. We want to use the service features as we can. So there's a few different services involved where we can take advantage of security features that are built in. So this is API Gateway. So with API Gateway, you have the ability to validate the input before you actually accept the API request. And you do that by specifying the shape of the payload, right? The shape of the JSON payload in that request. There's 3 different configurations, right with an API gateway, you can say only validate the body, validate the query string parameters and headers, or validate all of that. And you specify this using OpenAPI, right? So this is a pretty simple OpenAPI definition, or at least part of it, where I've defined some model that has first name, last name, and some account ID, right? And you can even give it like the pattern for that account ID if you wanted to. This is a great first step because, again, API Gateway is just going to kind of say, hey, oh, this doesn't match what I expect it to, and just return it to the user without actually invoking, or return the error to the user without actually invoking our Lambda function. This is going to predominantly fall probably in the security platform realm. I see developers doing this a little bit less. You can also attach another service like AWS WAF to API Gateway. And here you can use something like managed rules to protect against SQL injection, cross-site scripting, command injection type attacks. WAF has managed rule sets that focus on the OWASP top 10, for example. And there's also third-party rule sets. So there's a rich number of options available to you here that we don't have time to deep dive in, but there's probably a session elsewhere at reInvent this week on it. And then Lambda. So this is where your development teams might get involved. You probably want to validate or verify the input in your Lambda function as well. And this extends beyond just web APIs, by the way. I'd actually encourage you to think about kind of validating that payload no matter what event source is invoking your function. And there's some great tools out there that can help you with this. One of my favorites is an open source project called Power Tools for AWS Lambda, something a bunch of our colleagues have built. It's available for Node, TypeScript, Python, Java, and .NET today. And it has a kind of input validator. This is showing it in Java, where we specify the schema of the input in JSON. In TypeScript, it's using Zod, for example, another open source package. But it will actually check the payload, and it will throw an error if it doesn't match what you expect. You could also consider strict typing. A service like AWS AppSync, for example, which is managed GraphQL, has more strict typing. Or again, you can use some of the modeling in API Gateway to do this. So I am a big fan of using this across all of your event sources where you can. It's a great way to catch problems, too. All right, let's talk a little bit about least privilege, because again, this is kind of a core concept. And I like to encourage people to start training your developers, the people building this stuff, to understand least privilege as well. There we go. Because again, they're delivering not just application code in this world, they're also delivering some sort of infrastructure definition. And often, with that infrastructure definition, no matter how you write your application code, there's going to be some sort of IAM policy associated with it. So whether you're building a Lambda function like we're showing here, or a step functions workflow, even EventBridge, once in a while, needs an execution role to allow it permission to interface with other AWS services. And a lot of times, customers tell us that they're concerned that developers are going to pick an overly broad policy because it just works. I mean, who hasn't done that? I have. So we're going to come back to that comment in a minute and talk about one approach you can take to manage it. But again, we want to train our developers to hone in on a specific policy that just allows the essential set of permissions that resource needs to do its work. And I'm not talking about the developer doing their work, right? We want developers, again, to have that ability to innovate and try new things. But the permission sets that they create, the policies that they create, we might want to constrain. So my recommendation generally with execution roles for things like Lambda functions and workflows is that you create a unique role per resource where you can. There are some limits that you will hit at very large scale. And again, assign as fine-grained permissions as possible. Really look at that policy. If there's a star, you probably want to think about what's going on, although there are valid use cases for that depending on the service. And just keep in mind that this is a journey, right? You may not get least privilege right on the first try. I actually have this bad habit of giving too little privilege at times, and then I get a bunch of access denied errors before I sort it out. Not a bad problem to have. But you're going to want to set permissions, test the access, And don't just test the access locally, right? Actually deploy out to AWS, run some integration tests, make sure that things work the way you expect them to, and then over time, refine what you're able to do. So this might take some cycles. But let's go back to that problem I mentioned earlier about overprivilege or creating policies that allow kind of role escalation or permissions escalation. So there's a pretty powerful feature in IAM that's been around for a little while. I do see customers using this quite a bit called permissions boundaries. And essentially what permissions boundaries allow you to do is set the maximum effective permission that a role or policy that your developer creates. So even if your developer goes and builds something that has loads of permissions, even admin access, you can use permission boundaries to scope those things down. So these are guardrails for your builders. And the intent here, and what I like about this approach, is that we can start pushing the creation of policies, the creation of roles, over to the folks that are actually writing the code and know what they're doing, right? So that if you have a central IAM team, they don't become a bottleneck in creating and managing these things. Because again, go back to Josh setting things that are too limited, right? Then if I have to keep going back to some team and iterating on it, that's going to take time. So the thing with permissions boundaries is it actually took me a little bit of time to wrap my head around it. So we're going to spend just a few minutes, and I actually have a video demo because it's hard to show in person. There's a lot of CLI commands, and I would have fat-fingered something. So here's a quick example for our Lambda function, right? The Lambda function earlier, it needs to write something to a DynamoDB table. So I might create a role or a permission set that looks something like this. Everybody's looking at this. If there's any security people in the room, they might be, sorry, that was loud. Heart might be beating fast, right? But they can perform any put operation on EventBridge at this point. DynamoDB star is a little scary depending on what you have in Dynamo, right? They could delete the table, and that's what we're going to do in the demo. And then you can even do an SNS publish. I wasn't part of it, but I threw something else in there. So it works, right? If I go and test this, it's going to work, even if I deploy to the cloud. It's not least privilege, though, right? So how does this work? So when we create a role for our developer, they're probably logging in using something like Identity Center or some other tool to assume a role that gives them the ability to do their work, to create a Lambda function, to create a DynamoDB table, to create an EventBridge rule, whatever it might be. We want to give them the flexibility to do those things. We don't want to stop them. But what we will do is attach a couple of different policies to the developer role to kind of push some requirements on them, both when they create a policy and when they create a role. But we want them to be able to do those things, but we want to require that the permission boundary, which is just another IAM policy, we just want to require that that IAM policy is always attached whenever the developer does create a role or put a role policy or attach a role policy to a role. So basically what we're saying is anytime the developer touches a policy, it has to have this permissions boundary policy associated with it. If you have questions, I'm happy to talk towards the end afterwards. Cool, we'll stick around. The other thing is we're going to associate a couple of other policies with this developer role that prevents them from deleting the permissions boundary, obviously, or disassociating that permissions boundary requirement policy from their own role. So we're really going to try to enforce this idea that the permissions boundary needs to be there when the developer goes and creates things. So we're going to hop into the AWS console. Hopefully the text is all large enough to see. But this function, it's written in Python. It's going to try to delete a DynamoDB table, right? Probably not something we want to do in a Lambda function, but something that the policy allows for. So let's see if the video wants to start. There we go. So there's our code. And then I'm just in Cloud Shell. This is just going to run some CLI commands. So I've got a function policy. That's the same one that we just looked at on the earlier slide that allows DynamoDB everything. And I'm going to try to attach the policy. Oh, I'm sorry, I created the policy there. It just came back and said, OK, you can create this policy. That's fine. Clear things out. And now we're actually going to try to attach the policy to a role that I already created for this particular function. Access denied, right? Why? Because the policy associated with that developer role requires that the permission boundary policy be attached to any role that this developer is managing. So now we're going to go put that permission boundary policy on the Lambda function role. Did that. And in a second here, there we go. We're going to now try again to attach the role policy. And because that permission boundary is there, that succeeded. Now we're going to try to, we're just double checking the function configuration. You can see that that policy or that role is now attached. And now we're going to try running the Lambda function just by testing it. And I'm just using a blank test event. It's not really looking for anything here. So we're going to invoke the policy. And if all goes well, we get an error, right? So access denied in this case. So even though the role had a policy associated with it that should have allowed it to delete the table or drop the table, the permission boundary kind of limited the effective permission around what this thing was able to do. So hopefully that helps a little bit. I personally, I'll admit, I had some trouble wrapping my head around how this thing works. But there's a great example out there on GitHub, linked from that QR code. And again, these slides will be available afterwards. That shows some really good examples of the type of developer role and the type of broad permission boundary type policy you might want to use. Right? We want those permission boundaries to be wide and reusable so that we're not creating loads and loads of permission boundary policies out there. Now, if you want to limit what your developer can do, I'd recommend using IAM or service control policies, SCPs, which we're going to touch on just briefly in a minute. We're not going to deep dive into SCPs because they're a little outside the realm of application. So with SCPs, we apply those at the organizational level, and it basically will restrict, not ever allow, just restrict what everyone but admins in that org can do. So whenever granting permissions, it does define the maximum permission for IAM users and roles. And in this case, we are basically requiring that any Lambda function that gets created has some owner tag associated with it. Why might you do this? It makes it a lot easier to find whoever owns that particular function from a deployment standpoint. So if the owner tag is null or it's not even included in that function when it gets created, it's going to get denied. Maybe a little bit more interesting SCP. So this one actually prevents the creation of public API gateway endpoints. We have customers that do this, right? They only want their developers building private API gateways. So in this case, this SCP will actually prevent you from creating anything but private endpoints. So SCPs have a little bit more far-reaching control. These are really going to be in the realm of your security team and your platform team. Again, we wanted to focus more on application best practices. And to take you a little bit further, I'm going to hand it over to Higgy.
Cool. Thank you, Josh. So again, my name is Higgy, and I've been covering serverless for some time. So we do want to think about now building on some of the least privileged concepts that Josh has been talking about, the use of IAM and really these temporary credentials. The fact that these credentials that you're going to use to access resources, that these are all short-lived credentials. So again, this is all going to be powered through IAM and the fact that we can use this common policy language across a variety of different actions that we're going to be taking. So one thing that we may want to think about, and Josh referenced this a little bit earlier when he was doing the introduction here, is there's two different ways that we can think about interacting with AWS. The first is going to be these control plane actions. And again, these control plane actions are simply management actions that you're taking within your account. So this could be something like, I want to create an AWS Lambda function. I want to create a step function state machine. I want to create an event bridge bus, as an example. So these are management actions that you may be taking. And if you think about it, you can think about who's going to be taking these actions, or perhaps what is going to be taking these actions. So maybe in your developer environments, or maybe in your sandbox environments, these are lower environments, no production data. Maybe these are isolated from your production networks. So there's nothing really going on within those except for what the developer is testing. maybe you're going to allow the developer access to these type of control plane actions. However, when we get into things like maybe this is my UAT environment, this is my staging environment, my pre-prod environment, and of course your production environment, of course in this room, no one would allow a developer to interact directly with some of these type of control plane actions. And therefore, maybe you're going to have some type of automation pipeline, maybe like a CI/CD pipeline, where that pipeline, the build step, or maybe the deploy step, will have actually an IAM role that will then have allow access to some of these control plane actions. And then, of course, on the other side of that is data plane actions. These are going to be things we're going to dive a little bit deeper into in the next couple of slides. But this might be things that your application is actually doing. So if you're going to be invoking a Lambda function, or maybe you're going to be starting a state machine, or maybe you're going to be putting an event in an event bridge bus, or maybe into an SQS Again, you're building these serverless applications. These are these data plane actions that you want to think about. And Josh started off, we had that architecture diagram. We have an API. It invokes a Lambda function. And then it maybe writes to a DynamoDB table, maybe then accesses some other internal API. All of these, as Josh said before, there's a diffuse perimeter around each of these components as you're building your serverless architecture. And we're going to want to then wrap them with different IAM policies. So Josh mentioned SCPs. There are also resource-based policies, which again, we're going to cover in the next couple slides. There are then also like VPC endpoint policies, which again, I'm going to cover shortly, along with your IAM execution roles. So why don't we look at the next one? So here we have Lambda functions. And again, I was talking to a few folks earlier on, and I heard there were a number of folks using Lambda in production to run your compute workloads. And again, there's these two different policies or these two different IAM concepts that we want to think about. The first is a resource-based policy. And the simple way that we can think about this is who can invoke my function? Again, in this Lambda context, right? And this is going to be for both synchronous and asynchronous invokes. So an example, like Josh had pointed out earlier in that architecture diagram, I have API gateway. Maybe I have a REST API end request coming into my REST API endpoint. We then want to invoke a Lambda function behind it because that method was called. And this is where you would then have a resource-based policy on your Lambda function that then defines that says API gateway is my service principal. But then you can also specify specifically that it's coming from a very particular Lambda function, or even, if you want to get very specific, a Lambda function version or a Lambda function alias, right? So we can get very specific with these qualified ARNs. Again, as Josh had mentioned before, we want to try to avoid star, and then we want to get very specific with our resource policies. On the flip side of that, then, is your execution role. And again, the simple way that I like to think about this is, what can my Lambda function do? Right? So again, in that example architecture, my Lambda function is going to be maybe reading and writing from a DynamoDB table. So I have a very specific set of actions, maybe put item, get item from that table. And then along with maybe accessing some other internal APIs. So again, if I'm accessing or making an API call to API gateway, maybe I'm going to then allow access to invoke particular resources and methods for there. And then furthermore, this is also for poll-based invocations for your Lambda environment. You may be aware that Lambda provides you with like this poller that will do some of this work on your behalf, like reading and reading from Kinesis or from Kafka, MSK, SQS, et cetera, right? So this might be where you're going to apply some of these execution roles. So just maybe another example, we have Event Bridge here. Again, where you could use this resource-based policy. Again, this is the policy that says who can take this data plane action. And then the execution role, again, this is something that's going to be assumed and then will allow some action to happen here. So the example here is maybe I have, again, maybe as you're building out your AWS environment, you have a multi-account strategy. So maybe there's some shared account, maybe account A, and there's a bunch of events coming in here. And maybe there's a line of business account, account B, that's taking some actions. And maybe this central account, you want to publish events. You want to put events into this line of business account, account B. So the way that you could think about this is in account B, they can create an execution role. And the principal in that policy, in that trust policy, will say, I'm going to allow account A to assume this role. And then in account A, this shared account, when we're putting these events, this would then allow it to assume that role, which would then allow it to put events into the event bus sitting in account B. So again, this is, again, another way we can think about some of these serverless resources across accounts. In addition to composing your applications using some of these serverless integration resources, you may also, of course, have persistence layers, right? So a lot of times when we think about Lambda in particular, we say, your Lambda compute environment is really a stateless environment. You shouldn't really be storing state within those execution environments or those sandbox environments. But you would want to externalize that into some other type of persistence layer. So AWS, of course, I'm sure you've perhaps attended a bunch of these sessions. You may have heard of some of the recent announcements. Many AWS databases support IAM credentials, right? So this short-lived credential, this is what we would recommend if available for the type of databases that you're using. So for example, if you're using Neptune, Elasticache, of course, DynamoDB. These are services where you don't need to think about storing credentials or database credentials, et cetera. You can just use IAM as you would with your execution role. That said, we do recognize that some of you may be using databases that maybe don't have that native IAM support, and then you're going to need to manage these credentials in some way, right? And so in this scenario, we prefer using some type of credential provider or credential manager on your behalf. And again, we're going to dive a little bit deeper into that. Rather than using environment variables, we recognize that there is a convenience factor to that. And that said, it does allow those that have access to read those environment variables to then see those credentials, which again, we want to steer away from. It probably goes without saying, but I'm just going to say it anyway. Please do not hard code your credentials into your code and check them into repositories. I'm sure none of you would do that, but I should state at least the obvious. Another pattern that we do see with some of our customers is that they're going to actually front their database with some type of API. So rather than accessing it directly as a database, maybe I have a JDBC provider, rather than having to connect via JDBC connection, I'm actually going to connect just as an API. And again, now if you have this API front end, you then can use all the benefits of IAM and these short-lived STS tokens. Again, this is things like API gateway, AppSync, ALB, et cetera. You could even go as far as saying, maybe I'll add an API key. Maybe there's things like throttling or identity management we want to do in there. Or perhaps you could go even into OAuth, OAuth 2. That can get very deep, so we won't go much farther in there. One other thing that we're going to talk about, we can also talk about thinking about secrets manager or parameter store, which we're going to get to in a slide or two. OK, one thing that we also want to think about, again, for those familiar with the lifecycle of how a Lambda function invoke works, there is a particular lifecycle. So you may be familiar with this idea of a cold start, or what we call the initialization. What we want to ensure is when you're writing your code, again, we talked about you wouldn't hard code any of your credentials. We also want to think about when you're writing your code, when am I retrieving those secrets? When am I retrieving those credentials that I want to use later in my function invoke? One thing to be mindful of is when you do that cold start or that initialization, that happens once for the lifetime of that particular execution environment. So you could actually save some of this information or maybe these credentials in memory. This way, on a subsequent invoke, you're not actually retrieving those credentials again. And we're going to talk about some downstream impacts of that. And one of the benefits here now is because you're now just accessing those credentials from global memory, your code now might be faster, but also we don't overwhelm that downstream credential provider. The reason for this is you could imagine if your Lambda functions are invoking at scale. So again, we talk about Lambda function concurrency. Again, how many of these functions are invoking in parallel? What you can almost imagine is if I'm getting these credentials every time my function is invoking, let's suppose, again, we just went through Black Friday, Cyber Monday. Maybe lots of people, again, if you're a retail organization like Amazon.com, and you have lots of customers now purchasing products on your web front end, lots of requests coming in. If you're accessing and getting credentials every single time, you may be DDoSing your own internal credential provider. And so again, this is an opportunity where you can actually get that on init and then reuse that during your function invoke. So again, we want to be very mindful of scaling behavior of how Lambda is going to be scaling, along with how we're interacting with these credential providers. Well, one nice thing is, again, Josh talked about like power tools before, some of these things that AWS developed to make it easier for you as a customer to build applications. Well, we also provide you with what we call a Lambda extension, right? And so there's a secrets manager and parameter extension. And what we do is we just try to make this a little bit simpler. So for example, what we can do is within an extension, again, we won't go too deep into that. That's another session that you could perhaps look into. And there's also additional information if you look at the QR code on the bottom. But essentially what happens is we're going to stand up an additional process next to your function environment, next to your function code, your function process. And you can think of it essentially as an HTTP endpoint. And that will do the work, actually, of going and retrieving the credentials from that credential provider, like secrets manager or parameter store, because you can specify which secrets do I want or which credentials do I want to go and preload. You could even set a TTL. So if you know that that will not expire for 60 seconds, maybe 5 minutes, 10 minutes, whatever value is appropriate for your organization, you could set that TTL. And then your function code now, instead of making an SDK call directly to secrets manager or parameter store, you actually just make an HTTP call to a local endpoint, right? So you make that local endpoint call, and then you will then go and retrieve it. One thing that you do want to make sure is that you have some try-catch exception within your function code, just to make sure that if maybe that credential is expired, you do have some logic in there to then go and refresh those credentials in the event. By the way, this extension also will do refreshing based on the TTL that you provide. But again, you could imagine there could be some type of race condition in there where it didn't yet expire in the extension, but it did expire when you retrieved it. So again, something to be mindful of. This is, again, one of those things that we want to do to help make this easier for you in doing this credential management. All right, let's continue on. So thinking about another topic here is we want to ensure that we're only allowing authorized access into your applications. So one way to do this, of course, is if you're using API Gateway as your front door, maybe you're using AppSync as your front door. Again, if we go back to that example that Josh had introduced earlier before, we can simplify this, but also separate concerns, right? So Josh had talked about you have the platform builders, you have the app developers, but then you also have this security team. So this security team, maybe you're thinking about all of the security policies, the ways that we want to write our policies within our organization. We can offload those security concerns from your developers. Again, not to say that the developers aren't thinking about security at all, but there's a lot of in-depth consideration, a lot of in-depth design that needs to go into security. Especially with this API auth, you could have that security team really handle a lot of those concerns. You could then expose that as a Lambda authorizer. So when an API request comes into Amazon API Gateway, what will happen is before we pass that request to the back end, in this case a Lambda function, this authorizer will actually be executed and will perform the appropriate authorization logic, which we're going to get to in a moment. And then again, assuming that this authorization is allowed, it will then allow for this Lambda function to be invoked. The Lambda function itself, again, we talked about using a resource-based policy, so API Gateway was allowed to invoke this function. Your Lambda function now has an execution role, which then allows it to access that DynamoDB table. So let's dive a little bit deeper. So one way we can do this is using what's called Amazon Verified Permissions. Right, so this is Amazon Verified Permissions uses what's called Cedar. It's an open source policy language for your security team to then define fine-grained permissions for your end users. Right, so let's suppose we have an example here where we define a fine-grained policy for this user Audrey. Again, this is maybe a health application. They're actually coming in from Clinic IL123, and it has a bunch of these other additional attributes. Maybe we want to actually say we want to restrict that Audrey to only create or update. Those are the actions we're going to allow, and maybe health records, maybe personal profile. That would be the resource that Audrey would be allowed to take. So if we look at this flow here, you can imagine maybe Audrey's in a web browser or some type of mobile client. They make an authentication request to your identity provider. Again, it could be Cognito or maybe some other identity provider that you as your organization might use. Again, it comes back. We get this token. Then it makes this API request. So your client application will make an API request to Amazon API Gateway with this token. Now we invoke this Lambda authorizer. The authorizer now, this is, again, what your security team wrote, and will perform some amount of logic associated with this. And the logic here is essentially, we're going to make a call to Amazon Verified Permissions. We're going to take that token that Audrey provided me, and then we're going to evaluate that against the Cedar policy that your security team wrote. Right? So now we can actually check, is Audrey allowed to update her personal profile, as an example. Amazon Verified Permissions will then respond with essentially an allow or deny action, which then your Lambda authorizer could then respond back into API Gateway. So when API Gateway gets a response from this Lambda authorizer, it will essentially see, is this request allowed or is this request denied? Assuming this request is allowed, we then allow it to invoke the Lambda function, which then does all of the work associated with whatever that API call might have been. So here's an example of one of those Cedar policies. Again, this is an open source language. You can actually go and look at the GitHub repo to see and learn more about it. But here's one example. If we look at that first line within the permit function here, we start with the principal. Again, you'll notice that this is very similar to other IAM policies. So here we start with the principal and in my API. So my API is the namespace that you defined within your identity provider. So if you're using Cognito, this might be that user pool. The next thing that we're going to say is this property of user groups. So essentially what we're saying is, and then in that last one is US East 1 ABC 1234, that's the identity pool. And then within that identity pool, there's a particular developer. So essentially what we're saying is this incoming user is in Cognito and is in a particular pool or user group that is going to be verified. Then we say this action, again, within this MyAPI space, takes this particular action. And here we have essentially an API request. We're going to say the get method for the user's resource. Again, we leave resource here because we're going to then say, because we've already specified the resource in the action, we're good to go. Right, so that's an example that when your Lambda authorizer is making a call to Amazon verified permissions, it's using Cedar on the back end. This could be an example of a policy that's being evaluated. Okay, so we talked a little bit about authorizing those incoming requests. Another topic from that paper that Josh mentioned earlier was around preventing unintended access to sensitive data. Right, so again, Josh had mentioned earlier that, again, within AWS, we do have this shared responsibility model where AWS really takes really secures that underlying infrastructure. But there is that shared responsibility where we're trying to teach you today around how do we apply least privilege as we're building these serverless applications. And we're going to talk about some strategies or some techniques around some of the other peripheral things as you're building and deploying those serverless applications. So again, Josh mentioned this one before. Is around data encryption at rest. I won't read through all of these. I'll just highlight a couple of them. I think a week or 2 or 3 ago, Lambda just announced CMK support or customer managed key support for your zip packages, right? So we've had some customers where they say, we love that you use service keys when you're encrypting certain things within your serverless resources. But sometimes organizations say, we need to manage those keys. That's part of our security and governance policy where we manage those. So this CMK allows you to bring that. So we recently announced that support for zip artifacts with Lambda. Another one, maybe this was 1, 2, or 3 months ago, Step Functions also allows for this CMK support. Right, and this was really important for one of my customers, and I'm sure for many customers, but one customer in particular. They were really concerned around operators seeing that state transition data in the state functions, and they wanted to be able to encrypt that and perhaps block operators from seeing some of that state transition data. Well, by enabling CMK and then not giving the operators access to decrypt using the CMK, operators would just see a blank for some of that state transition data. So again, this is just one example where some of this encryption at rest was able to help some of our customers using CMK. One other thing that we could think about here is around using private endpoints, right? And so again, we can dive a lot deeper on private link. Again, there's a lot of other sessions on here. But again, another security posture could be, let's just use a private network within our Amazon VPC. And this could be an example where with API Gateway, you have clients that exist within your VPC boundaries. And you could then create a private REST API. And then you would use a private link endpoint to do that. And here you have a couple of additional security benefits here. One is you could apply a security policy on that VPC endpoint to restrict requests coming from a particular VPC. You could also apply a security group on that private link endpoint so that maybe source security groups are only allowed to then transit through there. So again, this gives you additional security posture from a networking standpoint. And before, Josh talked about WAF as it pertains to cross-site scripting, et cetera, but we can also use AWS WAF from a networking standpoint as well. So again, if you have public endpoints, and maybe you have scenarios where maybe you want to region lock some of your APIs. You don't want API requests coming from particular geographies. So you could do something like that. Or even if you want to do like an IP deny list. Maybe you want to block certain IP addresses. Maybe there are malicious actors that you don't want accessing your APIs. You can, again, do that using AWS WAF in front of your Amazon API Gateway endpoint. One other thing that we see with some of our customers is maybe you have sensitive data. Again, I have some financial services customers that have PCI data. Maybe you have healthcare life science customers, or if you're in healthcare life sciences, maybe you have PHI data, personal health information, or again, just general personally identifiable information. This might be something where you want to maybe you want to mask, or maybe even want to block that data from passing through your applications. With SNS, you have the ability to do that. So you have this ability to essentially apply a regular expression. And again, we provide a number of these out of the box. These are managed regular expressions. Or maybe your development team wants to build some custom regular expressions. This allows you, if you have data flowing through that SNS topic that has some of this sensitive information, you can actually potentially mask it so that maybe they're masked with a bunch of pound signs. Or it just gets blocked. You don't allow that to pass through. And this could be situations where you have some particular data sensitivity requirements. OK, so we continue to talk about a lot of these least privilege. One thing that Josh talked about before also was around who are the different personas, right? So we see the security team, we see the platform team, and we see the development team. As much as we want to continue to think about how we enable the developers to both innovate, but also do it with a secure baseline, there are also platform considerations. So your platform builders are going to be building some of these security guardrails into your deployment pipeline. So some of these things that we can be thinking about, one is using AWS counts as boundaries, right? And so we often talk about reducing blast radius with a multi-account strategy, right? So maybe your line of business team is deploying an application, and we want to restrict that within a particular account so that maybe there's sensitive data in another account. We're going to allow access to that sensitive data using some of these IAM principles that we've been talking about throughout this talk. One other thing that we've been talking about is also throughout that software delivery process, we want to ensure that we have good guardrails in place. Again, we can think about this from a security standpoint, but also from a governance standpoint. So maybe you have compliance rules and you have policies that we want to ensure that maybe when a developer is authoring code or maybe these infrastructure templates, that they have these guard rules that prevent bad configurations or bad properties from being configured. Again, you could do that as you're checking that into your source code repositories. And then again, you can do that throughout the process. And we're going to talk about some of those tools. So one thing that you may want to do is, from a security standpoint, you've deployed hundreds, maybe thousands of Lambda functions into your AWS accounts. And maybe some of these don't change very regularly. I have some customers that are using Lambda maybe to do some infrastructure auditing within their environments. And that code doesn't really change because they're dynamically reading some of these policies from some other API provider within their organization. This could be a scenario where maybe you're using a library. So this is an example. Here's some Python code where I'm using the request library. And if you can imagine, maybe I'm using the request library version 2.19.0. Again, I know it's in a little bit light of a color, but that actually has an open CVE against it, right? And so as an organization, if you've deployed the request library at this particular version, you actually have an open security vulnerability. But if this is a Lambda function that you've deployed a year ago and you're not actively maintaining, you may not even be aware that that Lambda function has an open security vulnerability to it. Well, Amazon Inspector has the ability with standard code scanning, or with standard scanning, to essentially scan your dependencies within your Lambda function. So it would actually identify that this request library is actually vulnerable. It will then give you a notification along with a report that gives you all of the information around the active CVE and a recommendation of what you may want to do to resolve that security vulnerability. The other side of Inspector is then code scanning. So for dependencies, we have standard scanning. And then for looking at the code inside, this would be code scanning. So before I talked about no one in this room would ever hard code any credentials. Well, Higgy's a terrible developer, and I wrote this code. And I tried to check this into my code and actually run it into production. Well, all of you are going to shake your heads and say, no, Higgy, that was a terrible idea. Well, supposing somehow it got missed and actually got deployed into production, Amazon Inspector with code scanning would actually detect this. It would see that you're actually hard coding credentials in your function code and would, again, give you a report notification to say you have a vulnerability in your code. This should be remediated. Again, furthermore, we can also do things like runtime anomaly detection using Amazon GuardDuty, right? So this is a scenario where, again, I know a couple of years ago there was a lot of cryptocurrency mining and folks would want to try to take advantage of AWS compute resources. This is something where GuardDuty can actually detect, hey, I'm observing in your VPC flow logs there's some anomalous behavior. Maybe this is unintended behavior that your organization doesn't want happening, and you could actually then bubble up some of this anomalous behavior by using GuardDuty. And this can work for both functions that are attached to a VPC. So again, maybe you have a scenario where your functions are operating on maybe RDS databases, maybe they're using Elasticache, and therefore they need access to your VPCs. But this also works for functions that are not attached to your VPCs. And again, these would be within the Lambda VPC. So again, all functions will operate within a particular VPC, but maybe these just have access to the public internet. Right? And so again, you want to just ensure that any of this traffic is being monitored by your security team. And again, last but not least, before we start to wrap, again, you could then use Security Hub. Security Hub is this single dashboard where you could start to look at some of these security insights from GuardDuty, from Inspector, and again, a number of other different security aggregation things that we're doing here in AWS, and we bubble up some of these insights. So here's an example where you see some of these software vulnerabilities, and we try to provide you with a dashboard to summarize this information so that your security team can actually then prioritize what are the most critical security aspects that we need to address today, right now. Maybe there's a zero-day vulnerability that just popped up that we need to address immediately, and maybe that's associated with a layer that we just deployed. Well, you could actually figure out how to get to identify that list and then take action as an organization. Okay, with that, I'm actually going to turn it over to Josh. I know we have a short amount of time left to take us home.
Thank you, Higgy. So just a couple quick reminders to sum things up. First off, remember, security is a collaboration across teams. We can't just sprinkle security on at the end like magic pixie dust. But having some collaboration, no matter how you're organized, is really important to take advantage of all of the different best practices we went through today. Some principles to think about. Implement least privilege, right? It feels like something that we need to train everybody on, remind everybody on. Again, we prefer using IAM wherever possible. We talked about some different ways to do that, some of the different data sources, even using it with API endpoints, where you can take advantage of IAM as opposed to using different credentials. Apply defense in depth. You can take advantage of a lot of these best practices in concert. Leverage some of the deep integrations across AWS services. GuardDuty with Lambda is actually one of my favorites, especially because it doesn't matter, like Higgy said, if it's, your Lambda function is associated with a VPC or not. And then take advantage of automation whenever you can. A couple of other sessions you might be interested in at reInvent later this week. One of them is a hands-on workshop where you can take advantage, actually use some of the things that we just talked about. It is right upstairs in about an hour if you want to check it out. And then there's a couple of other sessions you might want to take a look at on Thursday, including one that Higgy's doing on private workloads using API Gateway. If you want to learn more about serverless, a bunch of different resources that you can take advantage of, including some digital learning badges. And with that, thanks all for joining us today. We appreciate you taking the time. Please do take a minute to fill out the survey. We'd love to see 5s in there, but if you do have feedback for us, that's the best way that you can share it with us so we can make the session better in the future. Thanks so much. Have a good week at reInvent.